Okay, fourth graders, today we're doing Module 5, Lessons 16 and 17. Okay, we're going to look at these two lessons together because they're both about using pictures to help us add fractions and also subtract fractions. Now, what kinds of pictures have we learned how to draw when it comes to fractions? What's one? Anushka? Tape diagrams. What's another one? Sanvi? Area models, or they're also called rectangular fraction models. There's one more that I'm thinking about that we've used quite a bit. Haruto? Number lines, very good. So today we're going to see how we can use all of these different kinds of pictures to help us add and subtract fractions. Okay, after talking with your table group, who ran farther? Did she run further in the morning or the afternoon? Everyone? Morning. Let me ask you an extension question. How much farther did she run in the morning? Garrett? 1/6 of a mile farther in the morning. Very good. So she ran further in the morning. Okay, now, here we go. The directions tell us to solve by using a number line. Okay, so go ahead and copy down the first question. 3/7 minus 2/7. You can see I wrote it out using word form here. But if I wanted to use fraction form, it would look just like this. 3/7 minus 2/7. We already know what the answer is in our heads, right? If I have 3 of something and I take away 2, how much is left? 1. And what kind of units do I have here? 1/7. So we know the answer is 1/7. So today, are we really learning, for this problem, are we learning how to subtract? No. The focus isn't the subtraction. What is the focus? It's using the number, or using the pictures to show it. So right now, we're going to see how we can use a number line to show our thinking. Okay, so I need a number line. And if I'm working with the units sevenths, that means I have to divide the distance between 0 and 1 into how many equal size parts? 7. Go ahead and do that. And you may do it pretty evenly. You also might be like me and not. It's okay. Because all you need to do is label it to show that they're sevenths. That's 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, and of course 1 is the same as? Okay. So when we are showing the subtraction, we start with 3/7. So we're going to show we're at 3/7 right here. And then we're going to take away 2/7. So we're going to take away 1/7, take away 2/7. I'm going to show that this is taking away 2/7. When I take away 2/7, where am I on the number line? 1/7. Good. So this is how you can use a number line to show that 3/7 minus 2/7 equals 1/7. Let's try it again. This time we have 8/6 minus 5/6. So again, we're going to have a number line. And we're going to start with 0/6, also known as 0. And then I'll have 1 here. If my units are sixths, I need to split the distance between 0 and 1 into what? Sixths, right? So there's half. Sixths. 6 equal sections. So I have 1/6, 2/6, 3/6, 4/6, 5/6, and of course 1 is the same as 6/6. Now I have 8/6 to start with. How do I have 8/6 here? No. So what do? I know that 1 is the same as 6/6. So if I have another 6 here, would that be 7/6? And would this be 8/6 here? Right? Do you guys agree? So I'm going to start at 8/6 now. And I'm going to take 5 away. So 1, 2, 3, 4, 5. If I subtract, and I'm going to label that I'm subtracting 5/6. When I subtract 5/6, what am I at? Everyone? 3/6. So what is 8/6 minus 5/6? 3/6. Does that work out with what we know? If I have 8 of something and I take away 5, do I end up with 3? Good. So you need to be able to show that using a number line. Now, the directions tell us to solve using a number line, and we want to decompose the sum or the difference. And we want to record our answer as a mixed number. Okay, so here we have a subtraction problem, 12/6 minus 3/6. Use a number line to show how you would solve it. Go, practice. I know that 12/6 is the same as 2. So when I start at 2 and I take away 3/6, I end up at 1. And this is 1 and 1/6, 1 and 2/6, and 1 and 3/6. Do you guys agree? So what's the answer? 1 and 3/6. What's 9 minus 3? Everyone, what's 12 minus 3? 9. So what's 12/6 minus 3/6? 9/6. Is 9/6 the same as 1 and 3/6? Because if I had 9/6, I could take out one whole. How many 6 are in one whole? Everyone? 6/6. If I take out 6/6 or I take out one whole, how much is left? Everyone? 3/6. So I have 1, because it's the same as 1, and 3/6. So as a mixed number, my answer is 1 and 3/6. And I can show it using a number line like so. Okay. We can also use a number line to show addition. If I have 3/8 plus 7/8, I can show that I have 0 here, and 1 here, and 2 here. Now, this time, do I still want to divide my units into sixths? What do I want to divide my units into this time? Zara? Eighths. Let's go ahead and divide our units into eighths. Okay. Now, how many eighths am I going to start at this time? Sanvi?
3.
So there's 1/8, 2/8, and 3/8 right here, right? We'll start at 3/8. And then how many eighths am I going to add to it? 7. So I'm going to add 1, 2, 3, 4, 5, 6, 7/8. And I'm going to label here that I'm adding 7/8. Now, when I do that, do you guys notice that I went past the 1 part? What's another way to say 1? How many eighths is 1? I let 8/8. I went past 8/8. I went 2 more past 8/8. So really, this should be 10/8. Do you guys agree?
Yeah.
Okay. Because what's 3 plus 7? 10. So if I had 3/8, but I add 7 more, I should have 10/8. But I went past the 1 marker, which means I have 1 whole, don't I? Yes? So if I take out 1 whole from 10/8, how many eighths would be left? Everyone? 2/8. Okay, so that's how you write it as a mixed number. Talking about number lines, we can also model subtraction in 2 different ways, okay? One is, so the directions tell us to model each subtraction problem with a number line and solve by counting up and subtracting. Let me show you what I mean. If the problem is 1 minus 3/4, I can think of the 1 as 4/4, right? So I can think of this as 4/4 minus 3/4, which is, of course, 1/4. This is the subtracting way. We call it the subtracting way because you can see that we are subtracting. But if I want to use the opposite, the inverse operation, I know that 1/4, I can go backwards, right? 1/4 plus 3/4 should equal 4/4. 1/4 plus 3/4 will equal 4/4. Do you guys agree that that's how you could check your work, right? And we can show that using the counting up way on a number line. We can say, you know what, if I have 3/4, how far would I have to count up to get to 1 whole? Well, I have to go 1/4. Okay, so when the directions tell you to solve by counting up, that's what it's talking about. When the directions tell you to subtract, that's what it's talking about. Okay, let's try this on our own. Okay, so it says to use counting up and using subtraction. Okay, let's do subtraction first. Go ahead and write 1 and 1/5 minus 3/5. Now, when I have 1 and 1/5, I can think of that as I have to make it into to subtract, I have to make it into a improper fraction. Right now, it's a mixed number. 1 is the same as how many fifths? It's the same as, Swarnima? 5/5. So I can think of this as a number bond like this, right? What number would it be altogether? Arnav? 6/5. Good. Okay. So I can rewrite this problem. Instead of writing 1 and 1/5 minus 3/5, I can write it as 6/5 minus 3/5. Do you guys agree? Now we're ready to subtract and also to count up. Okay, let's subtract first. If I have 6/5 and I take away 3/5, let's use a number line. So here's 0/5, 1/5, 2/5, 3/5, 4/5, 5/5, 6/5. Okay, 4/5, 5/5, 6/5. If I have 6/5 and I take away 3, 1, 2, 3, how many fifths am I at now? Everyone? With confidence? What am I at now? 3/5. Good. We can count up in the same way. We can think to ourselves, okay, if I have 3/5 and I need to get to 6/5, let's count up. 3/5 plus 1/5 is 4/5, 5/5, 6/5. How many fifths do we have to count up? 3/5. Okay, so we can use the number line to help us count up or to subtract, but the answer is 3/5. Okay, so when we subtract fractions, there are two ways we can think about it. Okay, and this is what I've been teaching the 5th graders, so it should sound familiar to you. One way is to start with a whole number. Now, if our problem is 1 2/5 minus 4/5, do we have a whole number to begin with? What's our whole number part? 1. We're going to actually change the problem, okay? We're going to ignore the 2/5 part of the problem first. We're going to just pretend the problem is 1 minus 4/5. If I do that, by the way, will I get my actual right answer? No, because I changed the problem. 1 is not the same as 1 2/5. Which one's bigger, 1 or 1 2/5? Everyone?
1 2/5.
How much bigger is it? 2/5 bigger. So which one's going to have the bigger answer? The original problem or my modified problem? Which one will have a larger sized answer? Go ahead and talk about it at your table group. If I start out with more things, will I end up with more things? As long as I'm taking away the same amount? Yeah. But we're going to modify the problem and we're going to make it smaller to begin with because it's easier to think about a whole number. Does that make sense? Okay. What do we have to do to fix our modification later? We just have to add back 2/5. Does that make sense? So because in our heads we know that 1 minus 4/5 is what? If I have 1, but I take away 4/5, what do I have left? Everyone?
1/5.
1/5. So is my final answer going to be 1/5? No, because I took away the 2/5 from the start. So I have to add back the 2/5 now. So I can do 1/5 plus 2/5. Oh, can you picture a number line in your head? What's 1/5 plus 2/5? Everyone?
3/5.
So my actual answer is going to be 3/5. So one way that we can handle subtraction problems when there's a mixed number is to take away the fraction part first, but then add it later. Okay. Another way is to make it into an improper fraction. If I have 1 2/5, I can use number bonds, can't I? I can think of the 1 as how many fifths? 5/5. Right? Instead of 1, I can think of it as 5/5. And I can use a number bond to combine those two parts. How many fifths do I have now? 7/5. So I can think of this problem, instead of 1 2/5, I can think of it as 7/5 minus 4/5. Think of your number line in your head. If I have 7/5 and I take away 4/5, how many fifths do I have left? 3/5. Very good. Okay, so you can see that we got the same answer, 3/5, using the two different methods. The first method is modifying the problem and just starting with a fraction. And the second one is to make improper fractions.